All right, hello guys. It is 4 o'clock. It is Friday, and that means streaming. And I'm just gonna wait a second for the stream to catch up with me and make sure I did all my connecting of things correctly. I did. Excellent. All right, and make sure you guys are hearing me. Yes, that looks good. That looks good. Excellent. Okay. Oop. Maybe a little bit less bad on the ears with that adjustment. So today we're going to be jumping right back in to our emoji prediction project using deep learning. Sorry, taking a little coffee sip. Keep my energy levels up. I do gotta change these so they're not literally the last thing I do in the week, because I'm always tired by this time. But I am excited to hang out with you guys, so that's the benefit. So let's start our notebook. Let's see what I do this week. I was actually at an Emoji Conference Monday, Tuesday. It was a lot of fun. Got to see my friends, got to hang out, got to see the hot new emoji research. I live tweeted the whole thing, so if you want to go check out my Twitter, I use the hashtag Emoji 2018. And I got a lot of inspiration. And I want to sort of finish this project so I can start working on other things. And also we had a little bit of some technical difficulties with some of our kernels, which should all be resolved now, but if you were running into trouble, I'm so sorry about that. I also was running into trouble. It was very frustrating. Engineering team was working real hard to make sure we got back to where we wanted to be, and we should be good now. So let us know if you're running into any other trouble, and we'll definitely take a look at that. All of our imports. So last time we sort of threw out everything we did the first time and forked a different kernel, basically. And we did get to a point where we had a neural net that was generating emoji sequence predictions, but, oh, let me take that off so it's not making noise. But it was just generating long strings of emoji, and it was never generating an end of sequence token. So in order to get to the point where we can generate end of sequence tokens, what we were doing was we were padding our input so that everything was the same length, but if there were just two emojis, it would be character, character, and then spaces until the end, so that we had something that was the same length as all of the other ones, or as long as the longest emoji sequence, which I believe was 40 characters. I don't remember what this was. I remember this was sort of copied and pasted from somewhere else, and I don't exactly remember why. So I think this is just the number of messages. And these aren't actually messages. These are emoji sequences taken from both tweets and I believe also YouTube captions, not captions, YouTube comments. So we've got sort of a variety of, what am I looking for here? Genres here. We have a variety of genres. And what we were doing, so what we'd done originally was we just sort of, you know, stuck it all into one long string, and then we'd sort of gone through, and I think our span length was like 3 or something, so we did the first 3, and then the second 3, and then the third 3, and then the fourth 3, like so on and so forth, like that. And there's a character in here that's a space. So we chopped it up that way, and we fed it into our neural network that way. And that was perfectly fine, and it did work, and it did generate things. But again, it didn't ever generate the end of line token, which is what I wanted. And I'm wondering, now that I think about it, so instead of padding, I guess something that we could do is inside this sort of like space, we could do an end of line token, but I don't know what that would be in Python. Let's see. Python end of line token. Python 3 end of line token. blah, 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 parsers, line structures, logical line by the token Newline. Okay. And how do we put that in? Implicit line joining, blank lines, indentation. That's confusingly indented, blah, 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 blah. Oh, okay, so this is actually in the code itself. This is not in text. Escape sequence. Oh, actually, is this? String and byte literals. String literals are described by the following definitions. String byte literal. Short bytes, unsyntactic. Formatted string literal. So Unicode. So I'm just reading and making noises so that you know that I'm still here. Smarty says, I missed the earlier chunk, but prints a new line, but I think you might mean something more complex. So, yeah, basically so these are each emoji spans from different messages. So I don't want to treat these as like one long text. I want to treat this as a span, and this is the end of the span. Because right now when I'm training my network and I'm just generating, you know, a very long span that's sort of based on this, and it'll have spaces in it, but it doesn't know that that's the end of a message, and it should stop generating there, if that makes sense. Well, let's do all the things that we did before and see where we got up to. I remember we were having some trouble with the padding. So this is the number of unique emoji that we have. And then I think it was here that we were running into problems. Yeah, okay, so this is the, so we were using a span of 2. So this is using sort of like the length 2 spans. And here we got the length of the longest sequence. Okay, that looks padded. Yeah, okay. So we did get to the point where we were padding them. Neon Fuzz said, are you looking for something like, I think that's 2 quotes like that? Maybe? Let's see. Python 2 quotes. So that's just an empty string, right? And I'm not, so as I mentioned before, I'm not super familiar with Keras in Python. I've only used Keras with R before. I know. Don't look at me like that. I'm trying to use more Python. And they're kind of fairly different, even though I'm using the TensorFlow backend for both of them. So I'm still getting to grips with the ins and outs. So I think this would just make my inputs hard to parse. We'll see if I can't get the padding work out. Neon Fuzz says it's supposed to be /n, not an empty string. Maybe it's rendering wrong. Yeah, I don't see the /n, so that would be like that, right? Yeah, let's try that. Let's give that the old college try, actually. So I'm going to comment out this block. Is that the only block where I do weird things? What I should have done and what I didn't do is I should have committed this the moment I forked it and the moment I got it working the first time, so I'd have a version of it where it worked. But I did bad version control and instead just went all gung-ho. Changing up new things. Okay, I think we should comment out this, and I think it's alt slash. So I'm gonna do escape, and I think it's F. Nope, that's fine in our place. Escape H. Yeah, there we go. So if we want to block comment out, I know there's a shortcut for this. I just need to remember. Command palette, block, no, comment, no. I know that this is possible. I have done this before. Also, this is not rendering good with the amount of zoom that I have. It does not look great with the eyes. Control/P, blah, 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 blah. I know this is taking a minute. It is definitely going to block, comment, Jupyter. What is it? Control/. All right, let's try that. Control/. Nope, the other slash. There we go. I think we can get rid of these. I think we can get rid of these. I think these were just trying to figure out what the data structure was looking like. So I think this is where we are. So now I just need to find, aha, so instead of joining with a space, let's join with a new line. Yeah. I think that's good. Well, let's run it. Let's see. Oh, name X is not defined. Interesting. So it looks like, okay, so this is what we want, where there's a new line in between. And it makes sense that it's showing up multiple times here because we're doing our sort of a little sliding window thing. All right, and we're running into an error here in our model fit bit. The bit where we're doing our model fitting, not our Fitbit. We're not modeling a Fitbit. So we're doing fine here up until we did the X and the Y. And we should have been doing that. So that's the X and the Y is, this is the input string, this is the output string. So this should be the first one basically, and this should be the second one. And if we had 4, this would be the first 3, and this would be the 4th. And we're not generating it well. So it should be happening here. So I think actually I shouldn't have commented this out. And my white space is bad. Thank you for letting me know about that. All right, that should be good. So if we do that, that's not gonna work. Name last emoji is not defined. Okay. I think here I replaced something from the original kernel with something else. So what I'm gonna do is I'm gonna look at the original kernel. You can see I only have the one version. And I don't think it has the original code in it. I think I did this after I did all my stuff. Although maybe I was very smart and didn't. No, yeah, this is definitely after I did all that other stuff. So I'm going to go back and look at the original kernel that I forked this from. So I'm just going back to the landing page for this kernel, and here I can see that I forked it from this, and then we're going to use the original code to generate the X and Y. There we go. So this looks the same to me. Max length, characters, sentences. Okay, so it looks like we also changed some variable names in here that I'm sure I was trying to do to make it easier for me to understand what was happening. Sentences, next characters, emojis, sentences. And the characters we don't have is last emoji. Last emoji is not defined. Okay, so where am I defining last emoji? Nowhere. I don't say last emoji anywhere. Okay, so where am I using it? Okay, I think this should actually be that position in the sentence. Yeah, because this is the ith index in the sentence in this enumerator object that was made over sentences. Oh, is there supposed to be sentence and sentences? Sentences, sentences, sentence. Sentence, sentences, sentence. Next cares. Oh, no, I was wrong. Okay. And next cares is what we have called next cares dot append. So it's this little bit here. Let's see. Next cares dot append. Next cares dot append. I didn't change it. It should be the same thing. Let's see. Okay, next character definitely exists. So I just need to put it in here. And she's training. Okay. Yeah, we'll see if this works. I think if we're including the Newline character as a character, probably we should have a longer span. So let's see, what was it originally? That was my chair. Let's see, so here, max length, here's what we set it to. So instead of 2, let's actually set this to 4. No, to 3, I think. Well, what's our shortest sequence? We should set it to our shortest sequence plus 1 is what we should do, because then we'll be able to generate we'll be able to look at in one sort of pass the entire sequence. And then the plus 1 is because we're adding the /n character. So I think we can, I know at some point we got the length, the number of lines, but I want the minimum length. At some point I asked for the maximum length, so I think we can just ask for the minimum length as well. Let's see if that'll work. Shortest emoji sequence. 2. Okay, so our max length should be 3 because that's 2 plus the Newline character. How's that training going? Good? Is it? Okay, oh, it actually is training. It's just generating a lot of Newline characters because they're the most common character now. So that's the thing that's happening. Okay, and as we do more training, oh, sorry, if we have lower diversity, then we begin to get longer sequences. Let's see, we're on epoch 15. I think we only had 15 epochs. Excellent, so it is generating sort of like single sequences now, and we can tell that each of these is another sequence. So I don't think Newline is actually what I want. I want something that will stop the sequence generation, maybe? Let's see. Like I said, I haven't used... also, this is not a illicit emoji sequence. Neither is this, neither is this. Those should be together. That's supposed to be the US flag. Okay, so we have some problems that we have run into. That's fascinating. Okay. Well, it kind of worked. let's try it with a slightly larger span. And actually, let's set this to be that, so that our span is the length of the shortest emoji sequence plus 1. All right. And I'm okay with the step of 1 because we have a pretty small data set, so this is good data augmentation. So now we should have, yep, you can see slightly longer sequences. Okay, one thing I do not like. You will see here that we are breaking apart the flags into individual flags. So what I'm actually going to do, if you look at the original data, you can see, you can't see. There we go. You can see that when I was originally doing this analysis, I removed the modifiers. So I removed all the skin tone modifiers. So here's the version with the skin tone, here's the version without, here's the version with the skin tone, here's the version without. And I also collapsed all the flags so that the flag of each individual country was a single A. And I think I'm going to do that again to get around some of these problems where skin tone modifiers are showing up randomly instead of modifying something. They are modifiers. That's how you get the different skin colors. I mean, that also could just be that our network's underbaked and we should do like another, I don't know, 10 epochs. But I think that the simplest solution is going to be to take advantage of the data cleaning that I did earlier. So let's actually, instead of emojis being emoji.emoji, emojis, whoop, no mods. Okay, and now I'm gonna get rid of a bunch of stuff that we don't actually need. No, first I'm gonna commit and run because it's working and I wanna save a version that's working instead of being bad at version control. So here's a version that's working, and then we're going to tidy it up a little bit. The downside is this does mean we have to train from scratch again. But you can see it's using the GPU, so that's nice. You can also tell, in addition to looking at error logs, you see the GPU is on down here at the top of the console. And you can also see the GPU's on if you go to the settings tab and then look at GPU and see if it's on or not. So there you go. And you can't use Docker images and GPU kernels right now, but if you have a non-GPU kernel and you add different, what's the word I'm looking for? Thinkums, doohickeys. Packages. If you add different packages, if you install them to your version of the Docker image, then that version will be saved. All right. Well, these certainly are some emoji sequences. Some of these don't look very illicit to me. They don't look like something that a human would actually produce. Like, yeah, that I get. I don't know about that. Like, I can construct a story where someone would say that, but it doesn't seem particularly human-like to me. And I think there's a good question here, like, so this is an emoji sequence generator, right? And the idea is that you can start with a seed and then predict what emoji would come after it. And the question is that something a human would do? Are these going to be human-like, you know, emoji sequences, or are they just going to be more or less random? And to what degree are the sequences of emoji that humans generate random, and to what degree are they structured? And my personal opinion is that they are less structured than other types of language usage. I don't think they're necessarily non-linguistic, but I think they're not, you know, they don't have a grammar, so to speak, capital G. And that is my personal position on the matter, and it is contentious. So know that I'm bringing you some hot takes from emoji linguistics. So if that worked, I can get rid of all these cells that I commented out earlier because I don't need them. Goodbye. This is what I spent the entire last time doing. Oh, well. And I'm actually going to move this into fewer blocks, I think. So define our model. Compile model. Goodbye, goodbye. This is very helpful text, but I don't need it right now. And these are just like helpful little what would you call these? Helpful little functions, and I'm actually going to change them a little teeny bit. So instead of 400 characters, I am going to do 10 so that our predictions are shorter. And I'm going to hide this so you won't see that. Get rid of this helpful text. Actually, let's scroll. Let's make sure that I didn't break anything when I made that change. And just retrain real quick. Okay. Oh. Okay, so I've made an error somewhere in my model specifications. Where did that happen? So one of the layers is wrong. It's expecting, so it's the first LSTM layer. It's expecting to have the shape to 649. So this is our sort of one hot encoding. And then 2 is the length of the input sequence, I think. But instead I got it right with the shape 3, 649. Do we get this same error if we run from the top? Because I think when I set my max length value, we don't. Okay, excellent. When I set my max length value, it should have sort of propagated down all the way down to the bottom. And I think I just failed to run one of the cells after that calls on the max length value after I generated my max length value. So 12. Oh, it's so much faster than training on CPUs, y'all. So much faster. Interesting. So this is just like, I think this is a random seed. I don't think this is a, whatchamacallit. I don't think this is one of the actual sequences. It could be. Let's see what they pick up here. Well, maybe it is. Yeah, maybe this actually is from the data set. So this is a green heart, Newline, bang. And then it generates just a bunch of new lines with a low temperature. And then, oh, sorry, diversity. And then if you make the temperature a little bit higher, diversity a little bit higher, you get more different things. And then if you make the diversity even higher, you get more different things. Okay. And now it's generating just the 10 items that I said instead of the 400 it was before. Interesting. And this does look like, well, maybe not this first, but this does look like something somebody would say on Twitter. This does seem to be fairly good emoji usage for me. This is not. This is, especially like this little bit in here seems especially non-human. But I think that it's, it's an empirical question. How do you know that a sequence emoji is good? And this is the question with like, text generation in general. How do you know that your text is good? Machine translation is a little bit easier because usually you have like a baseline that you can compute the difference between your generated string and the expected string, which is what the blue score is. But that also assumes that there is like one canonical translation between two phrases in two different languages, and that's, that's quite the claim, huh? Okay, so I'm kind of okay with this. So I'm going to go through and comment what each of these blocks of code is doing, and also get rid of a lot of the sort of explanatory text, just so it's a little bit more compact and easy for us to go through. Get the relevant column and add they're not summary statistics, but summary info. And then in this, conjoin all emoji into one huge string. And then this, get the indices of each character counts. So this is what is this doing? What would you call this? So it's creating this sort of sliding window across our data. I know it has a name, but it's not coming to me off the top of my head. Get all spans of that length with a step width of 1. And then here we are splitting spans into character to predict and preceding characters. Oh, there's no G in characters. Is there? Characters. That looks okay to me. Define the model, compile the model, some helper functions that we're not going to look at anyway, and then defining the checkpoints, and then, and this is using, I believe, a built-in keras function. But actually, let's find out what this model checkpoint function is doing. Model checkpoint. All right, tell me about it. Save the model after every epoch. Okay, that makes sense. File path is, okay, so we're saving our model in weights.hdf5, and we're only saving the best one. Okay, and then we're actually fitting the model. Okay, so checkpoint. Let's see. So our model is called model, right? Yeah. So let's actually check out the environment variables and see what it looks like. It's gonna be under M, or is it? Okay, so do we not have an object called model? This is not gonna be helpful. This is gonna tell us. Oh, okay. So the object is not, oh, that's right. Hello, Effie Coleman says hello. That's right. Keras does this thing where it generates and then modifies the model in place. So if I wanted to get it, blah, 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 blah. Okay. Wraparound self.call for handling internal references. Are near those. Okay. So if I actually want to do some text generation besides just sort of checking in while we were training the model, so I am making a emoji sequence predictor. So for a given input, it will predict, you know, output. And right now we don't have a way to sort of say, well, I don't have a way to say this is the end of the string except for Newline. So I would consider this to be the end of the string. Actually, I can probably say generate until you hit a new line. I think that's what we should do next, because I think that this on epoch end function we can cannibalize to get our, you know, generated, yeah, so it is taken from the data set. So I think we can cannibalize this function to get our generated thing. To generate our text, just return the function, I think. Sorry, that's what Epicolyman says. I think the first thing I want to do is, instead of doing for I in range, I want to do this while. How do you do while statements in Python? It would give an output and end the line. Which function is this, Epicolyman? While next car doesn't equal /n. All right, let's see if this will work. Oh, that did not work. Okay. Is it because my slash is backwards? Local variable next car referenced before assignment. Oh, okay. Well, I'm not allowed to do that apparently. So I should probably define and next car out of scope. You said you need to end the line, so whatever one that is. Just return the function. I'm afraid I'm not following. So, but let me walk you through my problem, and I think this will also help me as well. So each of these is a sequence taken from a different text, and right now we have this /n character between each sequence. And what I want to do when I'm generating something is I want to generate until I generate this /n character, and then I want to stop. And right now I'm just doing this with a loop that generates 10 things and then stops. So that's what this version was doing. And as you can see, keep scrolling. Scroll at the bottom so we can actually see something. It'll just keep generating. So I think we did like 400 characters here. So it'll just keep generating 400 characters, and it doesn't know that sort of the /n character is going to be the end of that line and that I want it to stop there. And the part of the code what is doing that is here. And I think this will work except for the pesky problem where next char is not defined. So I think I'm just going to define it in this scope like this. It's nothing. It's the empty string. Let's see if that works. All right. Still says it's being referenced before assignment. Let's try rerunning from the top and see if that'll... There we go. Haha. Awesome. So that is exactly what I wanted. That was fairly easy. I had to change one line of code. So what you can see here is that it's generating until it gets the next line. And here, the next thing it is generating is a next line. And this is a perfectly good sequence, and so it's saying the thing that I think would come next is a different sequence. So it's stopping generating there, and it doesn't generate past the seed. And then as we increase the diversity / temperature, I don't know what the difference is. I thought that this was called temperature. When we're saying, give us crazier things, I shouldn't say that, give us like more unlikely things. Then it's like, oh, it's not the next line, it's the train car, stop hand, pizza slice. And, oh, nope. Interesting. So it's generating, well, it kind of worked. Oh, okay. So it is working. It's just that this sequence happens to include this character in it. Okay. Yeah, I think it does work. I think that's good. Nice. What was I gonna do next? Let's see what checkpoint is. Here's .callbacks.model checkpoint. Generating sequences, Keras checkpoint. So we've saved this model to a checkpoint. And now I want to use that model that we've saved to actually generate new so I want to actually be able to generate new sequences, basically. So now that I've trained my model, I want to be able to, you know, generate 20, 30 sequences if I want them, or, you know, 5,000 or whatever. Okay. Save the model after every epoch. That's what we did. Where is it? I want to use it now. The model checkpoints will be saved with the epoch number and the validation loss in the file name. So it's in a file. Okay. So do I need to read it in? So it should be in the file weights.hdf5. So if we did open with well as Python, how do you open a file? Yeah, no, it's just open. I was right the first time. Look at me second guessing myself. Okay, so we are in this checkpoints folder apparently. Let's go up one. What's up here? What's in working? Yeah, there we go. Okay, so it's in working. I guess. Tell me the data type, I guess? It's D-type, right? Is it not D-type? Oh, I should probably call it something else, huh? All right, can assign function call. With model open. With file open. There we go. Nope. Nope. Yes. Okay. I know this is the dumbest thing. I just always forget how to do it. Open returns a file object. Oh, I have it backwards. You have to open and then give it a name. Ugh. How's y'all's Friday going? Now this should work and we should be able to see what the D-type is. We can't because D-type is not a thing? type is the thing? Do I gotta print it? Or I can't see it? I do indeed gotta print it or can't see it, I think. All right. It's a text.io wrapper. Actually, I think we just need to read. Okay. What if I print the model? Okay. What if I print the line in the model, I guess? Ah, there we go. Read. Oh, that's not a function. That's a method. Built-in method. Let's call this let's actually call that my model and call this model file. Try and keep it. Easy to read what these things are doing, and then type my model, except it's supposed to be underlined. Nope, that's also not an underline. There we go. Built-in function or method. Oh. Okay. I still don't know what this is. Printed a string? Yeah. Let's read some lines, because it might end up being like super long. Is it read lines? What? Or is that not that read line? Except that's definitely not how you spell read line. Okay. You know what? Kernel.com, Keras, LSTM, text generation. Let's see what we got. Beginner's guide. I definitely feel like a beginner right now. Let's see what they do. Preparing, we done that. Blah, 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 blah. What an LSTM is. Train. All right. Generating the text. Model.predict classes. Okay. Okay. I have found something to copy and paste. So we're gonna have to do model max sequence length. I don't actually think we're gonna have to do that much changing. Let's try this out and see if it works. And that worked. And now this is not going to work because United States is not a token that we have. And let's use poop laugh. That didn't work. All right, max sequence length is not defined. We've definitely defined something like that. Ah, it was max len, not max sequence length. Okay, name Tokenizer is not defined. All right, so where did you define Tokenizer? But it was lowercase, right? Oh, okay. So Tokenizer was just Tokenizer. I don't think I actually need to tokenize. I think I can get rid of some of this. So I don't think I actually need to do... Okay, let's figure out what he's doing and then do it. So this is for words and not characters. So the next word's argument is used straight up nowhere. This is never used. Oh, here we go. So this is how many words to generate, and I'm actually going to do this. And I think I actually want to get rid of this because again, I don't want to set sequence length. Instead, I want to do the same thing that I did up here and just generate until I generate a new line. Scroll. All right. Except now I gotta fix my white spaces. Okay. So I've gotten rid of that, and then model is just our model, which is called model, and then the max sequence length is our max length, I believe. So that's the maximum number, the longest sequence that we fed into our model originally. So excellent, no errors. And so then what we do is we take this seed text and we tokenize it, and we didn't import our tokenizer, so that's giving us an error. So let's do all of that in here real quick and just see if that works. I don't think it's going to work because this is for word level tokenization and we don't have that. Oh, maybe it will. No, okay, that didn't work. Tokenizer object has no attribute word index. So we are running into problems. So we are splitting our thing into tokens, except these are word level tokens and not emoji tokens, which are character level. So that might be a problem. And then we are padding them to the max length. We're putting text in front of them. And then we are predicting the classes for each of these tokens. So we're finding the closest thing in our model. And then for we go through our items in our tokenizer word index. The index is predicted, output word equals word break. Seed text plus math plus output word. Return seed text dot title. So it looks like it's predicting separately for each token? Surely not. That seems ridiculous. Okay, tokenizer text to sequence seed text. Interesting. Okay, what if we just got rid of all of this? Well, let's see what we're doing to generate text. No, outside here. Scroll up here. So predictor NP0s 1 max length of length characters 1 through max length. So this is the same thing we're doing up here. Okay, so we're creating a sequence X. So what I would expect us to be doing is to be looking at our sequence and to be adding it until it is adding tokens to it until it is the same length as our max length sequence minus 1. Well, let's see what it's doing, just like a little bit of it. Let's figure out what the bits are doing, and then we can figure out where we're going astray. Okay. All right. So can we just do model predict class of our little emoji friends right here without having to do any of the rest of this pre-processing? Is that gonna work? String object has no number of dimensions. Okay. Okay, so it's not expecting a string, it's expecting an array, I think. So let's, is as.array a thing? String to numpy array. All right, so let's do np.fromString and then give it this string. Okay, so now we're giving it an array, and it was throwing an error because we were giving it. Okay, error when checking. Expecting LSTM for input to have 3 dimensions. We got an array with shape 1, 1. Okay, so when we just create an array, we're doing something wrong. Yeah. Yeah, that's not, nope, that's not the, well, okay. Okay, yeah. So when we're trying to create a numpy array from these little funny emoji guys, we get a very small number, and that's it. So that's not the thing that I wanted to do. Okay. What if, all right, what if we put a space in here? Okay. So the problem seems to be with the tokenizer. And we did not, when we were initially putting things together, use a tokenizer. We used this. So let's actually just copy and paste this and see if this works. So instead of splitting it into tokens, do it this way. And I think I got, yeah. And then just, let's just, and I think this is not gonna work because it's expecting things here. Let's go back up. Okay. Generated is nothing. Let's just do this. And then print. So this is what we're using to generate text up here. Let's use this instead of all of this folderol. Let's get rid of all you. And let's call this a thing and put it in a function. And we're gonna indent you one time. And let's see, let's call this generate emoji. Emoji seek. What's the syntax for declaring a function again? Neonfuzz says mp.array list emoji. That might work. So at one point we one-hot encoded, and the thing is we're gonna have to go back and redo all of the one-hot encoding steps. Because otherwise, so if you're one-hot encoding and you have like column 1 is A, column 2 is B, but you didn't have any C's, so column 3 is D, and then you go back and re-encode, but you do have C's this time, then column 3 will be C instead of D, and you're gonna end up with, you know, mismatches and gibberish. Excuse me. I would like to avoid all of that. Excuse me. Def is the... And then it's going to take some arguments, and we'll figure out what those are later. So our sentence is actually, instead of this, it's going to be input cars, and we're going to ask for those. Input cars. So this was randomly selected from all of our things, what existed in our data set, and we're not going to do that. Instead, we're going to give it a sequence to generate. And we're going to start it with our little sequence we did. I can get rid of this. I can get rid of this. And then we're deciding what the next character is to put in it. And I'm actually going to try and be a little bit more consistent with I'm adding code. So we're going to start with nothing as the next character. Well, the next character isn't /n. So whenever we have a line break, that's the end of the sequence. And we're going to treat it like that. Expred. So this is the things that we are feeding into the neural net because it's expecting, I think our max length is 3, so it's expecting 2, and then y, the last one, is, so it needs to know max length because that's not defined anywhere in here. And then the length of cars. And it doesn't know what that is. All right, so where's cars? Where are we defining that? So this is number of unique emoji. All the way down. Okay. Cars. I'm actually going to do this one. So I can take notes on what each of these are. Number of unique emoji. Max input length seed characters for prediction. Okay. So all these are fine so far. Car is, oh, we're enumerating over the sentence, which is so far just our input characters, but as we add more, it'll include that. Indices car. Oh, we also need to fit in car indices. Let's look for that. Yeah, I know it's right there. I can see it. No, I want to know where we define it. Okay, so this is also something we were defining earlier. So that's just a where we put things when we one-hot encoded them. And a lot of this we could probably add to a new function and save out. So I'm probably going to want to save something like which characters were which indices and distribute that with the model. Predict. That we've defined. Diversity. Let's do sort of like a diversity of 1. It's a sort of nice middle of the road diversity. All right. Okay. This'll work. Wow, it didn't, huh? Model and max sequence length. Oh, oh, that's because I called this generate emoji seek. All right. Well, key error. Oh, space. Of course, there's no spaces in our data set. It works. You can't see it, but I'm making a very pleased face right now. Nice. I'm not entirely sure what this space none is. We'll figure that. Well, that wasn't it. I'm not entirely sure where we're getting the space none from. Like this one down here at the bottom where it says none. Maybe this one? Nope, that was the wrong thing to erase. That made sense. Okay, well, I don't know where that's coming from, and I'll just make my peace with that. Congratulations. Oh, what if I just do a poop? Yes, yes. We can generate sequences, my friend. So I think that's gonna do it for today. I'm pretty pleased. I'm going to, I think, add a little to generate new sequences. Just add a little sentence to say what this does. Use the generate emoji seek function with a seed emoji. If the output is empty, it's predicted that there would be generated the end of the sequence after your emoji. Awesome. I'm pretty happy with this. I am going to, I think, commit and run it and make it public so you guys can play around with it if you want. Is it part of the next car string? Neon Fuzz asks. Very possibly. Let's scroll down. Next car sample parents. So it's sampling the predicate. Predictions. Sorry, not the predicate. And it is taking indices car. Where's this indices car coming from? Oh, that's right. That's right. That's the inverse of this. It's sort of like the, no, not the inverse, the flipped one. Maybe. That's my answer. Maybe. So let me make this public for you guys to take a peek on if you like. And if you can figure out where that none is coming from, I would be much obliged. But for the meantime, I think I'm gonna call it an evening. It's a little bit after I usually end my stream, but I was on a roll, and I'm pretty pleased. I feel like we wrapped it up and did a lot of copying and pasting and slight modification, which is you know, the way things work generally. All right, I will see you guys next week. Yes, next week, Yes. Week after that, no, because I'm going to be at IMCL. No, ICML. I'm going to be in Sweden, so I won't be streaming. But yeah, I'll see you guys next week. Bye-bye.